Okay, so continuing the last problem, sort of. In the last problem, we solved for delta S of this reaction. Now we want to know what is delta G, the Gibbs free energy. The equation for delta G is delta G equals delta H minus T delta S. As far as spontaneity of a reaction, we would like delta G to be negative, and so it is helpful if delta H is negative, and because of this minus sign, we would like delta S to be positive. Okay, so really what we need to do is just plug all these values in and just make sure all the units cancel, or the units cancel out. So delta H is negative 90.84 kilojoules per mole. But the problem is this is kilojoules and this is joules. We need them to be the same, so I'm going to convert this to joules by multiplying by 1,000. So delta H is minus 90,840 joules per mole. Minus T delta S. T is 530 Kelvin. This has to be in Kelvin because these units are in Kelvin. Times the value we got earlier, which is negative 221.5 joules per mole Kelvin. Okay, everything's in joules, the kelvins are going to cancel out, and we'll end up with joules per mole, which is the units, or acceptable units for delta G. Okay, so now we're going to plug everything in. We got negative 90,840, and then this minus and this minus are going to cancel out, so it's going to be plus 530 times 221.5. And I got a value of positive 26,555, which I guess we only get 3 sig figs, I guess, because of Kelvin. So 26,600 joules per mole, because the kelvins canceled out. Okay, so typically delta G is written in kilojoules per mole, so I'm going to convert it back. So delta G is positive 26.6 kilojoules per mole. If this were negative, this would be spontaneous, so this means this reaction is non-spontaneous. So this is an example where the delta H was very negative, a very large number. We expected this to be a spontaneous reaction, but because the delta S was very, very negative, it actually overwhelms the whole thing, and basically you end up with a positive delta G, which means it is non-spontaneous. Delta G is the deciding factor in this equation. Okay. You'll also notice that because delta S is directly multiplied times the temperature, at lower temperatures, delta S plays much less of a significant role. The higher this temperature is, the more delta S is going to matter.